I'm going to give you the second method for solving the Cauchy Euler equation. We transform this Cauchy Euler equation to the equation with a constant coefficient. Is higher order differential equations with constant coefficients. It's very interesting. Some of the books are only giving this method, that we shift this one to the constant coefficient. We are having the substitution x equal to e to power t, where x is bigger than 0. We take ln of both the sides, we get ln t is equal to ln of x. Then in our equation, we take the first, second derivative, third derivative in terms of the new variable t. That becomes the constant coefficient. And then it's very easy, as we have discussed before, with the constant coefficient, we apply the substitution e to power mt and we can solve it. I will give you an example and show you how we can shift this one, for especially transformation I want to give. We are having a dy by dx, and we can shift it to dy by dt. When I divide by t, and we are having dt by dx. If I take the derivative of this one, then what's the dt by dx? dt by dx is equal to 1 upon x. So what I'll get? I'll get here this equal to, this is equal to 1 upon x dy by dt. So I multiply here, I have dy by dx is equal to 1 upon x dy by dt, and then multiply by x, we get here x dy by dx is equal to dy by dt. So we change our x dy by dx to dy by dt. Now I'm having here, we'll take second derivative d by dt of d by dx is my second derivative, dy by dx is equal to d by dx of 1 upon x dy by dt. So we first derivative of the first function will be equal to minus 1 upon x square dy by dt, and derivative of dy by dt will be equal to 1 upon x d2y by dt square into dt by dx. We know the value of dt by dx. We get here this equal to minus 1 upon x square dy by dx plus 1 upon x square. Put the value of dy by dt is equal to 1 upon x d2y by dt square. Now I'm having here, this is my d2y by dx square. Now I take this term and I take this term and multiply by x square. When I multiply by x square, I get here x square d2y by dx square is equal to, I get here d2y by dt square minus dy by dt. So in this way, we just change our variable to t, and remember these three equations, and with the help of that one, we must use it and change it to the constant coefficient. These are the two, this is our transformation. And using this one, we get x dy by dx, and we get here x square d2y by dx square. I just write here these values here separately so that you will remember it and we have to apply it. We are having here x is equal to e to power t, x is bigger than 0. Then we are having t is equal to ln of x. Then we have x dy by dx is equal to 1. We are having here the value of this is equal to dy by dt, and we are having x square d2y by dx square is equal to d2y by dt square minus dy by dt. We apply this one, and I give the example. I give the example. I want to solve this Cauchy Euler equation by transforming it into the equation with the constant coefficient. As I told you, we are having the substitution x equal to e to power t, where t is equal to ln of x, and here our x is bigger than 0. And then I told you that we are having x dy by dx is equal to dy by dt and x square d2y by dx square by using transformation. We get here d2y by dt square minus dy by dt. We have changed the variable x to t. So substitute in a differential equation. We get here x square d2y by dt square. We get here d2y by dt square minus dy by dt. Now the variable, independent variable is changed to t. Then minus 2x dy by dt is minus 2 dy by dt. Then we are having 2y, this is equal to 2y. Now y is the function of t. We are having x cube. What's my x cube? I change it. I take here my x is equal to e to power t. What's my x cube? My x cube will be e to power 3t. E to power t, we are having e to power t whole to power 3, and this will be e to power 3t. So I get here this new differential equation, and that's my differential equation of the constant coefficient. So I simplify it further. I get here d2y by dt square minus 3 dy by dt plus 2y is equal to e to power 3t. Now this is my differential equation which I change to the constant coefficient. Now I solve this differential equation. To solve this differential equation, I use the substitution here. Y is equal to e to power mt. So I will get to the, first I find here the yc. Yc is for d2y by dt square minus 3 dy by dt plus 2y is equal to 0. And that gives me m square minus 3m plus 2 equal to 0 as I discussed before. Now I factorize this one. The factor will be m minus 1 into m minus 2 equal to 0. I get the roots. The roots of these equations are m equal to 1 and m equal to 2. So I get here my yc. My yc is equal to c1 e to power t. My variable is t, don't forget it, e to power 2t. So find yp, I have f of t. My f of t is equal to e to power 3t. So what's my yp? My yp will be equal to a e to power 3t, because here is the coefficient is constant. Now I substitute the values of y in this equation. We are having y dash is equal to y dash p is equal to 3a e to power 3t. Y double dash will be equal to 9a e to power 3t. Substitute differential equation. Our differential equation is d2y by dt square minus 3 dy by dt plus 2y is equal to e to power 3t. I substitute here. What I'll get? I get y double dash is 9a e to power 3t minus 3 times yp is 9 minus 9a e to power 3t. 2 times yp is plus 2a e to power 3t is equal to e to power 3t. Now here 9a is cancelled 9a. We compare the coefficients. We get here 2a is equal to 1, a is equal to 1 by 2. So what's my yp? My yp is equal to, I substitute here the value of a in this equation. I get here y equal to 1 by 2 e to power 3t. So I write my general solution. My general solution will be y equal to yc plus yp. So my y is equal to c1 e to power, here is my solution given, where I wrote the solution here. This is my solution. Yc is equal to c1 e to power t plus c2 e to power 2t plus yp. Yp is 1 by 2 e to power 3t. Now we are having our original variables in terms of x. So at the end, don't forget that we change a variable to x. What's my e to power x? My e to power x is e to power t is x. E to power t is x. Then e to power 2t will be equal to x square. E to power 3t will be equal to x cube. So my result, y is equal to c1 x, c2 x square plus 1 by 2 x cube. So this is my result. So as I told you, some of the books, they are not using the method we discussed before. They always change the Cauchy Euler equation to the equation with a constant coefficient, and then they apply the method to solve it. But you can solve this one by both methods as you like. So you can do more practice for the problem. We have examples solved with the help of the other method using y equal to x to the power m. You can change it to the constant coefficient by using these substitutions. I have told you how we find them, and then you change it to this differential equation is changed to the equation with a constant coefficient. And when we have the constant coefficient, then we know that our substitution will be e to the power mt, and we get here the characteristic equation. We find the roots, and this is our yc. This is our yc. We redefine our f of x. That's very important. So our f of x is equal to g of x is equal to x cube over x square, and that become x. And our x was, we have already defined that become e to the power 3t. You don't need to do it here because we are not using the this one, because here at the end we are having already the values changed. The coefficient is 1, so our f of t will be e to the power 3t. We solve this one. This is the way we can solve it. And again, we will inshallah continue with the equation with the these equations are with the variable coefficients. And these are difficult parts of the differential equation. This is a simple case because we take a special case for the Cauchy Euler equation. With the coefficients, we are having the Bessel equation, we are having the Legendre equation, and so on. So they are difficult to solve. I'm sorry to say this one, but this is true because we get the solution in terms of their function. Constant coefficients are easy. We are going to discuss the power series method next time with the solving the differential equation in any form with a constant coefficient or with the variable coefficient we applied. Thank you very much.